Hello everyone and welcome back to Chemistry Clarified. Today we are going to continue from where we stopped in the last lesson. In the last lesson, we talked about some types of separation technique. We did an experiment to show how you can separate soil from water using the filtration method. We talked about mixture itself, which is when a substance consists of two or more constituents that are not chemically combined together, that is, that are physically combined together. We also talked about other types of separation techniques, including sieving, distillation, magnetic separation, decantation, and sublimation. Today, we are going to be looking at more separation techniques and their application and uses. The next separation technique we are going to be talking about is fractional distillation. And this fractional distillation is very, very important. Remember, in the last video, the last one we talked about was distillation that can be used to separate two liquids that mix or liquid from its impurities. Now, this fractional distillation can separate a lot of liquids that are mixed physically together. An example is crude oil or petroleum. Crude oil or petroleum is a very, very important natural resources, and we need fractional distillation to separate this crude oil into its fractions. So, an example of a crude oil fraction is petrol. In some countries, they call it gasoline. So, another one is kerosene, and we also have diesel. We have a lot of useful liquids inside the crude oil, which are very useful. And to separate each of them, we have to use this fractional distillation. Now, how does fractional distillation works? It is simple. You have to put the mixture. In this case, the mixture is the crude oil, and then we have to put the crude oil into the fractionating column. When we put it in the fractionating column, we are going to increase the temperature, and then when it gets to the boiling point of each of the crude oil fractions, that particular liquid is going to evaporate. We are going to condense the liquid that has evaporated back into a liquid form. So, an example is petrol. When you have increased the temperature and it has gotten to the boiling point of petrol, so the petrol is going to boil and then it is going to turn to gas. Then the condenser will convert the petrol that is in gaseous form back to petrol in liquid form. Then you increase the temperature again. When it gets to the boiling point of kerosene, the kerosene is going to boil and it is going to become gaseous kerosene. And that gaseous kerosene is then going to be condensed back into liquid kerosene. When it gets to the boiling point of diesel, the diesel is going to boil and become gaseous diesel, and then that diesel you are going to convert it, that is condense it back into liquid diesel. Using this method, you can separate different fractions into their constituents and you will be separating the mixture. So that is how fractional distillation works. The next separation technique is centrifugation. And this centrifugation is one of the methods that we can use to separate insoluble solids from a liquid. For instance, if you have a blood sample in the hospital, so which is always in small amounts, so you are going to put that blood sample into a test tube. So after you have put the blood sample into a test tube, you are going to put the test tube inside a machine called the centrifuge. Now, when you put the test tube inside the machine called the centrifuge, the test tubes are always mostly plastic test tubes. So when you put it, you are going to on the machine, and the machine is going to spin those test tubes at a very, very high speed. This spinning will cause the particles of that particular blood sample to separate. The blood cell is going to come to the bottom, and the plasma, which is the liquid part of the blood, is going to be at the top. So, using the method of decantation, you can easily just pour out the plasma out of the test tube and you will be left with the blood cell. So this is how you can use centrifugation to separate an insoluble solid. Insoluble solid means a solid that does not dissolve. So an insoluble solid from a liquid. The next separation technique is using separating funnel. Now, this is how it works. When you have two liquids that do not mix together, for instance, if you have vegetable oil and water, and you know that vegetable oil will never mix with water. If you add both of them in the same container, the vegetable oil is going to come to the surface and then the water will sink to the bottom. Now, if you want to use the separating funnel method, this is what you are going to do. There is a laboratory apparatus called the separating funnel. It looks like this. This is how it looks, this particular apparatus. Now, you are going to pour the water and the vegetable oil, and then you allow it to sit there for some time. At the end of the day, you see that the water is going to come at to the bottom, and then the vegetable oil is going to float on the water. Now, what are you going to do? You are going to open the tap. The separating funnel has a tap at the bottom. So you are going to open the tap. When you open the tap, the water is going to start flowing through, and then when you get to the layer of the vegetable oil, you close the tap. So using this method, you have separated the water, which is now in your beaker, and from your vegetable oil, which is now left in your separating funnel. So that's how the separating funnel works. The next type of separation technique is evaporation. And this evaporation is used to separate soluble solid, that is a solute, from its solvent. And in the first video, we already talked about what a solute is, which is something that dissolves, the way salts dissolve in water. So salt is an example of a solute, and solvent is the water that is dissolving it, and both of them mixed together is a solution. So when you have a mixture of a solute and a solvent, like salt and water, so both of them are solution. Now we want to separate the solute, which is the salt, from the water, which is the solvent. So an example of this is seawater. In nature, we have salt, the table salt that we put in our food. It is present in seawater in abundance, and that is naturally occurring. In chemistry, we refer to table salt. The table salt we put in our food, we refer to it as sodium chloride, and this is its chemical formula, sodium chloride. Now, this sodium chloride, if you want to get it from our seawater, what are we going to do? We are just going to get a sample of the seawater, and then we are going to dry out the water. So we can do this by exposing it to the atmosphere, which will take a lot of time before the water will dry out. So alternatively, we can apply some heat to it. So if you apply heat, it is going to increase the rate of evaporation, and then at the end of the day, we are going to be left with our dry salt very, very faster. So that's how evaporation works. The next separation technique is crystallization. And while evaporation can be very useful when we are separating salts that are heat tolerant, that is, that do not decompose when we eat them, so we can easily use evaporation. But there are some salts, for instance, copper 2 tetraoxosulfate 6 pentahydrate. Now, let me put that down. Copper 2 tetraoxosulfate 6 pentahydrate. Don't mind this long name. You are going to get used to them later in chemistry. So if you are not familiar with names like this and symbols like this, don't fuse too much about it. Later in the video, we are going to learn more about naming compounds and things like this. Now, this salt, it decomposes easily on it. If you put it on fire, it is going to break down to another thing entirely. So to prevent that, we cannot use evaporation, because for evaporation to occur, we need heat. So, and we don't want it to decompose. So we are going to use another method known as crystallization. How does crystallization work? The first thing we are going to do is that we are going to use a water bath. A water bath is an equipment that we can use to increase the temperature of a substance gently. So it doesn't have a harsh effect like subjecting that particular solution to heat, to flame directly. So the water bath will just have water inside, and then you are just going to put whatever you want to evaporate inside that water bath. So it is the boiling water that is inside the water bath that is going to increase the temperature of that particular solution gently. Now we are going to put the solution containing this salt into the water bath. So, and we are going to let some of the water evaporate so that it can become saturated. That is, a lot of the water will have gone. So we'll be left with most of the salt. So now when the salt is a lot inside the solution and most of the water have gone, so we can now proceed with crystallization. So what is this crystallization? We just take it out and then we'll allow it to cool. When it is cooling down, we are going to see crystals of this salt forming. And when the crystal is forming, you are going to allow it to cool completely. When the crystal has formed out, then you are going to use a filter paper to collect your salt and then separate it from the water. Then the residue, that is the salt that is on the filter paper, you are going to dry it. When you have dried it completely, then you have your salt separated from water. And that is how crystallization works. Fractional crystallization also follows a similar process to crystallization. Just that in fractional crystallization, you need two or more salts that have different solubilities, that is, that dissolve easily than each other in the solution. So, for instance, salt and sugar, they do not dissolve in water in the same time. If you put salt in water in one container and you put sugar in another container with water, one is going to dissolve faster than the other. That means both of them have different solubilities. Now, when you want to do fractional crystallization, you need two or more salts that have different solubilities so that when you cool down the solution, the first salt is going to crystallize out first and then you filter it out. Then the second is going to crystallize out after some times. Now, if it is more than two, then you just continue repeating the process, and that is on fractional crystallization. The next separation technique is precipitation, and this precipitation is used to separate a solute, that is a soluble solid, from a liquid. Now, this method takes advantage of the different insolubility of that particular solute in two liquids. What does this mean? An example. Let me use an example to explain this. This salt, known as iron 2 tetraoxo sulfate 6. So this salt, iron 2 tetraoxosulfate 6, again, if you are not familiar with all these things, don't let them scare you. So we are going to get there in a few more lessons. So now, this type of salt dissolves in water, but it doesn't dissolve in ethanol. Because it dissolves in water and doesn't dissolve in ethanol, we can use advantage. You can take that as an advantage and use the difference in its solubility in water and ethanol to precipitate it out of the solution. What does this mean? When we have this salt dissolved in water, we are going to add ethanol. We are going to introduce ethanol to the water. Now, ethanol does mix with water. When ethanol has mixed with water, and remember, this salt does not dissolve in ethanol, and the ethanol has already mixed with water. So that is going to force the salt out of the solution, and it is going to precipitate out. Now we can now filter the salt out using a filter paper and then dry it to get our pure salt. So that is how precipitation works. The next separation technique is chromatography, and chromatography is very, very important in pharmaceutical industries, in criminology. So detectives, they use this So it is very, very useful in a lot of aspects. And how does this work? Basically, chromatography is used to separate solutes from a solution. And remember, a solute is something that dissolves. Now, ink, as an example, has a lot of color. These colors have dissolved in this particular ink. So if you want to separate those solutes, that is, these colors that have dissolved already in the ink, we can use chromatography. And how does chromatography work? We are going to get a chromatographic paper or maybe a filter paper and cut it into a strip. So we are going to spot the ink, just a little bit of the ink. We are going to put it at the end of the filter paper, and then we are going to dip it into an appropriate solvent. We are going to watch the solvent move up with the solutes, that is, with the different colors. Now, these solutes, they have different speed. They move at different speed. So each color is going to be moving at a different speed. The fastest will be at the top, and then the slowest will be at the bottom, and then the middle are going to be filled up based on their speed. Now, using this method, you have successfully separated each color that is present in that ink into a specific spot on the filter paper. And this is very, very useful in a lot of aspects. Now, that is all under separation techniques. At least that will be covering in this lesson. Now that we have looked at 14 types of separation technique, now let us examine how to test for purity. Remember, a mixture is an impure substance, and we are trying to use all these 14 separation techniques to make them pure, that is, separate them to their different constituents. Now, after we have used all this separation technique to separate our mixture into its various constituents, how do we test if what we are left with is actually pure? That is why we need test for purity. Now, the first one is using the melting or boiling point. If it is a liquid, then we are going to check the boiling point. For instance, we already know that water has a boiling point of 100 degrees Celsius. So let's say we used a separation technique method of distillation to get pure water, and we want to test if the water is actually pure. So what we can do is we should see if the water actually boils at 100 degrees Celsius using a thermometer, and if it doesn't boil at 100 degrees Celsius, if the temperature increased more than 100 degrees Celsius and the water hasn't boiled, that means the water still contains some impurity, because impurities, they increase the boiling point of liquids. Now, if it is a solid, how can we test for the impurity? We can use the melting point. We know that the melting point of water, again, which is ice, is 0 degrees Celsius. So if the ice should melt below 0 degrees Celsius, then we know that the ice is impure. Why? Because impurities, they lower the melting point of a particular substance. Again, another thing we can use to know is if it boils or melts at a range. Now, pure substances, they have these characteristics. A pure water will melt at 0 degrees Celsius. Let's say the temperature was at minus 5 degrees Celsius and it is still ice. When it increased to minus 4 degrees Celsius, minus 3 degrees Celsius, minus 2 degrees Celsius, minus 1 degree Celsius, it will still be ice. And suddenly when it gets to 0 degrees Celsius, it is going to break down immediately, instantaneously, and become water. So it will not melt at a range, but if there is impurity present, it might start melting at about minus 3 degrees Celsius, minus 2 degrees Celsius, it is still melting, minus 1 degree Celsius, it is still melting, 0 degrees Celsius, it is still melting. So that is a range. It doesn't melt immediately. The same applies to boiling. If it boils at a range, that means there is impurity present. And remember, under chromatography, when we're talking about separating different solutes from a solvent, so we said the different solutes are going to have different spots on the chromatographic paper. Now, if you do the same test for the pure substance and you have only one spot, you don't have different spots on the chromatographic paper, that means the substance is pure. Because if it is not pure, you are going to have different spots at the end of the test. So that's how you do test for purity. With this, we are going to be putting an end to this lesson. And if you are a person that likes videos like this, don't forget to give us a thumbs up, share this video to your learning group, and subscribe to this channel. See you in the next video.